In this lesson, we're going to be exploring periodic motion. So if you've ever taken physics, this will be review for you. If you haven't taken physics and you plan on taking physics, this is going to be important to learn. So the first thing we're going to be talking about are some definitions. So peak and trough. I have a diagram here, top left. It is a sine wave. We're going to be getting into that in the next couple of lessons, but more importantly, it's something that we're going to be calling periodic. So I'm going to get into a few examples. Just for now, I want you to be exposed to that word. The first couple of things that we're talking about are peaks and troughs. So if you look here, the peaks are the highest point. You can think of it like a peak of a mountaintop, and a trough is the lowest points. So I have 3 troughs here. Some people even say they think of a trough like a pig trough. So, a pig trough would look like this so that it could hold water. The next word or definition that we're going to be talking about is period. So a period is the interval of the independent variable. So the independent variable is often time, okay? It doesn't have to be time, but a lot of times it will be. Needed for repeating action to complete one cycle. So when I look at this diagram here, I'm just going to highlight, I guess, in yellow. I have one period, so I'll just start at a trough here, and one period is going to go all the way until I hit that trough again. So this length of time would be my period. Now there's no numbers on this graph, so I can't tell you what the period would be, but that's how I would calculate it. Now I can pick any 2 points to calculate the period. So if I wanted to start up here at this peak, I would calculate the period from that peak all the way to the next peak. And the last definition that we're going to be talking about is a cycle. So a cycle is very similar to a period, basically the exact same. So the cycle is a series of events that are regularly repeated, a complete set of changes. Now we're going to be going through some examples and you'll see the major difference between period and cycle in the next couple of slides. We are going to be talking about graphing motion. I'm not sure if when you were in grade 9 you did any little experiments with some graphing calculators where you walked back and forth and you were using motion to create a graph. If you didn't, you definitely talked about them. So you've seen questions like this, definitely in grade 9, for sure on EQAO. So here we have a distance time graph with this crazy looking graph. And so what this is saying is that here we have a distance of 0. And as we get further, I don't know why I can't write. As we get further along, the distance increases. Here is at a time of 0, and as we get further along, more time has gone by. What we notice with this first section of graph here is that we have a straight line, and if I look at what's happening, I'm just going to make some fake numbers here, but maybe it looks like there's been about 5 seconds that's went by, and maybe they walked, 5 meters. So this is actually motion away. Let me just get a different pen here. Now if I look at my next section right here, this is horizontal. So time is still going by, so here is 10 seconds. So it's been 5 seconds, but if you notice, there's no change in the distance. So what's happening here is no motion. Someone's just standing still. In this third section, it's been maybe another 5 seconds and they've went even further. Maybe they're at 11 meters now. And so this is motion away. And in this fourth and final section, it's been, 2 seconds. But their distance went from as far away as they were all the way back to 0. So this means motion towards. So they went back to where they started. Now, the information on the bottom is just kind of a summary of what happened here. So if we see a linear function, this means that we have constant speed. The steeper the line, the quicker the speed. And that should make sense because we know that slope is rise over run. So we're going to be talking about a distance or meters per time, so per second. And the peaks and troughs represent the maximum and minimum distances away from the starting point. So we have our peak here. So this point represents the furthest away we ever got. And a trough, I guess, would be here, which is at 0, which is the closest that we ever got. The last little bit of information that I want to give you is about a periodic function. So a periodic function is a function whose values are repeated at equal intervals. So I have 3 diagrams here, or 3 graphs. And the first one, when I look at it, I mean, it's not perfect. I drew it with my finger, but we can see that this is a very square pattern that's hitting the exact same peaks and the exact same troughs. We're going to imagine that each of these is the exact same distance. And so when I look at this, I am going to say, yes, this is periodic. Now when I look at the second diagram, I don't have enough information. All I see is that I have one cycle. So it started at a trough, went to a peak, and ended at another trough. I don't know what happens beyond either of these, so I don't have enough information to say that this is periodic. So right now I'm going to have to say no. Now if the graph even did this, then I could say that it is periodic, because then I see that when it hits this trough, it's going up towards a peak again on both sides. Now finally, this last graph hits a peak and then a trough, and then a peak and then a trough, and then a peak and then a trough. But this is not periodic. So in the definition, it says a function whose values are repeated. So when I look at this peak is higher than this peak, which is higher than this peak. So even though it's going up and down and up and down and up and down in a smooth way, it's not hitting the exact same values. So this is not periodic.